You are most welcome, viewer, once again. We are looking at testing for the polarity of a magnet. The word polarity comes from the word poles. We say the magnet has two poles, the north pole and the south pole. Supposing you are given a magnet and the person who gave you the magnet did not show you which side is the north pole and which side is the south pole, how do you know it? So we want to test for the polarity of a magnet. So you are given a magnet like this one. You don't know this pole, you don't know this one. That's why we are calling it X and Y. They are not known. So this is a magnet. As you can see, we have written here, a magnet of unknown polarity. This is the magnet you are testing. It is polarity. So for you to test for the polarity of this magnet, you need another magnet. This time you need a magnet whose poles are known. So you use the one whose poles are known to help you know the ones whose poles are not known. So this magnet is called a magnet of a known polarity. The polarities are known, the poles are known, south and north. But here we don't know X, we don't know Y. So what do you do in this case? You bring a magnet of a known polarity, one of the poles of a magnet of a known polarity, like this one is the north pole. You bring it near another pole of a magnet of unknown polarity, in this case near X. Now what happens? Immediately you see these two poles, these two repelling. What does that mean? It means this one is also a north pole. So once this one repels this one, automatically you know, since this is north, this must be north. Because from the law of magnetism, we know like poles do what? Repel. So that is how you test for the polarity of a magnet. Some people think that when you bring, supposing this one gets attracted to this one, then this one is what? Is south. That is true. But attraction is not the best way of testing for the polarity of what? A magnet. Why? Because if this one is south, surely it will get attracted. You will know this is the south pole. But if you bring a magnetic material, something which is not a magnet, but can be attracted by a magnet, supposing you brought an iron metal, it is not a magnet, and you bring it near here, what will happen? It will also what? Attract. So when this one attracts this, there are two things. This could be a magnet, or this could be a magnetic material. So attraction is not the best way of testing for the polarity of what? A magnet. The best way of testing for the polarity of a magnet is when you bring a pole of a magnet of a known polarity near a pole of a magnet of unknown polarity, and the two repel. Once they repel, then automatically you know this is north. And if this is north, automatically this one becomes what? South. Now let's put that in writing. So we shall say a pole of a magnet of known polarity is brought near a pole of a magnet of unknown polarity. Then you say, if repulsion occurs, then the two poles are like poles. As simple as that. So you can see testing for the polarity of a magnet. As brief as the examiner wants, and you'll get all your marks. The diagram is there, then you have explained. When somebody tells you to explain, it is not enough to mention one sentence and you think you have explained. You see, you can simplify your explanation by drawing a diagram. And then from the diagram, you go ahead and then you keep explaining. And when you're explaining, sometimes you state and then you give a reason. So here you can now get all your marks. This is how you test for the polarity of a magnet. A pole of a magnet of a known polarity is brought near a pole of a magnet of unknown polarity. If repulsion occurs, then the two poles are like poles. So if this was south and you brought it near this and they repelled, automatically this one also becomes south. And if this one becomes south, then the other one becomes north. But this is north. Because it is north, if they repel, then this is also north. And therefore this one becomes south. Now, let us move to another level. Let us move to another level. But before we go to another level, supposing there were 4 marks that you were supposed to be given here, how will the examiner award? The examiner may give you marks for the diagram. Then he goes ahead and then he looks at your explanation. You see, and you get your 4 marks. The diagram, then the explanations, and you get yourself 4 out of 4. Now let's go to another level. Let's look at some terms. Some time back we looked at some terms, but we did not exhaust them. Some of them will keep on coming. Let's look at another term. This time we are looking at what we call a magnetic field. A magnetic field. A magnetic field. What is a magnetic field? So a magnetic field is, so we shall say, it is a region around a magnet where a magnetic force is experienced. Very good. A magnetic field is a region around a magnet where a magnetic force is experienced. What does that mean? If you have a magnet and then you bring a small piece of nail, iron nail or razor blade, the distance between that razor blade and the magnet matters. If the distance is very far, automatically the magnet will not attract. But if the distance is very near, it will be attracted by the magnet. What does that mean? It is attracted because it is within the region of the field of the magnet. So a magnetic field is a region, and that region must be around a magnet, not very far from the magnet. And within that region, a magnetic force is experienced. Now, how do you draw a magnetic field? How do you represent a magnetic field? A magnetic field is represented by magnetic field lines of force. For example, if this is my bar magnet, is the north pole here and there's the south pole here. When you bring a piece of iron nail around here, near, not very far, it will be attracted. But if you bring it very far, like here, it will not. Why? Because it is outside the magnetic field. But here, it is within the magnetic field, which means magnetic field is a region, and that region is just around the magnet. And within that region, there is a force which will be attracting. A magnetic force is experienced. So, for you to draw a magnetic field, you use magnetic field lines of force, the lines of force. And these lines of force, they move from the north, they go towards the south. They start from the north and they go towards what? The south. So you put the arrow like this, like this. You see? So here they are entering. Here they are entering. So they start from here. It goes like this. This is how the magnetic force moves. It moves from north. It goes towards what? The south. Which means at the north, they are leaving. They are coming out. But at the south, they are entering. So in the middle here, we have a straight line. We have a straight line. But still the arrows, here they are going out. The arrows are going out. Here they are coming out in. So that is what we mean by a magnetic field. This, what I have drawn is, I've drawn what is called magnetic field pattern. And the magnetic field pattern shows the magnetic field. If you want to represent a magnetic field, you use the lines of force. So this is a magnetic field pattern for a bar magnet. You see, when somebody says, draw the magnetic field pattern for a bar magnet. A bar magnet means just one magnet. And you know one magnet has a north, and one south. So take note of that. But when you are drawing these diagrams, also you should ensure that these lines of force, they don't touch each other. We are going to look at that. Why they don't touch each other. So we shall now say here that a magnetic field is represented by magnetic field lines of force. Magnetic field lines of force. These lines we have just drawn, this one, and that one. We call them magnetic field lines of what? Force. So a magnetic field is represented by magnetic field lines of force. Now, the way you look at those lines, they have been drawn in such a way that they start from the north and they end at the what? The south. From the north pole and they end at the south pole. So we shall say these field lines of force, we are going to say these field lines of force, these field lines of force they start from the north pole and end at the south pole. Very important. So we have our magnetic field there definition. We have the magnetic field pattern showing how the magnetic field of a bar magnet is. And we are saying the magnetic field, whenever you are drawing, it is always represented by magnetic field lines of force. You know, so the lines must have arrows showing where they start from and where they end. We say they start from the north pole and they end at the south pole. So these field lines start from the north pole and they end at the south pole. Very good. Now, when I tell you, draw the magnetic field pattern of a bar magnet, when I'm marking, when the examiner is marking, he's going to use three things. One, he's going to look at polarity. Polarity comes from the word what? Poles. The poles there. Yes, the poles are there. North is there, south is there. Good. The next thing is the pattern. The pattern. How the field lines are. Here we expect them to bend. And then here they are supposed to be straight. In the middle, they are supposed to be straight. So the pattern. And then lastly, we are going to look at what? Direction. So your diagram should have all this. For you to get the correct marks that the examiner has decided to award. Like now here, the arrows are there. And make sure that all the arrows are starting from north and they are going to south. Should one arrow change, like this one, instead of facing down and it faces up, that means the diagram becomes wrong because the direction, the arrows are wrong. Okay? Now, we are going to look at another term. We have looked at magnetic field. We are going to look at what we mean by magnetic flux. Magnetic flux. What do we mean by magnetic flux? The definition is very simple. The magnetic flux, shall say, it is a group of magnetic field lines. It is a group of magnetic field lines of force. So magnetic flux simply means a group of magnetic field lines of force. Let me take you back to the diagram. This is what we mean by magnetic field line of force. How many are they? There are three. 1, 2, 3. When it is 1, you call it magnetic field line of force. When there are 2, you call it magnetic field lines of force, or you simply call it magnetic flux. So magnetic flux looks to be the plural for magnetic field lines. So magnetic flux is a group of magnetic field lines of force. But it is also good for you to know that magnetic flux is a vector quantity. So let's put it down. It is a vector quantity. What is a vector quantity? A vector quantity is that quantity which has both magnitude and direction. So magnetic flux is a vector quantity. It has magnitude, it has direction. That is why we are saying when you are drawing these diagrams, this one, the direction should be there because the direction shows the direction of the magnetic flux. Now, we are going to look at a different thing. This time, I'm taking you back where we started from. As I rub very fast, I want us to look at properties. Properties of magnetic field lines of force, and we underline. So we are looking at what? Properties of magnetic field lines. Property number 1, they start from North Pole and end at the South Pole. So when you are drawing the magnetic field lines, the way I already explained, the arrows should start from North Pole and they should end from the South Pole. Good. The second one is they don't touch each other. So when you are drawing the magnetic field lines, make sure they don't touch each other, as it is in this diagram. You see, they start from the north, the arrows, and they end at the south. Then secondly, you see those arrows, the lines, they don't touch each other, meaning that they don't touch each other. Next, they don't cross each other. See? So when you are drawing them, make sure that they don't cross each other. Next, they are closest. They are closest at a point where the magnetic field is strongest. Very good. So let us add all of them. Next,